significant figures in calculations. Specifically, we'll be dealing with addition and subtraction rules and also multiplication and division rules. The main reason behind significant figures lies in the fact that all measurements have mistakes in them. If we measure the pencil down at the bottom of the paper, I can see that it is definitely 15 centimeters, and it is maybe 16, but maybe not quite clearly 16. So therefore, I might estimate that at 15.9 centimeters. Because all measurements have errors, scientists have used and developed significant figures as ways to reduce errors in calculations. One of the things we'll be discussing is precision. Precision really comes down to the number that has the more decimals, the more precise the number. So the first number up here, 25,111.001, is considered the most precise. It is considered the most precise because it has the most number of decimal places. In this case, it has 1, 2, 3 decimal places. The next number down has 2 decimal places. The third number here has 1 decimal place. And these two at the bottom have no decimal places. So they are considered the least precise. The ones that are most precise will have the most decimal places. In addition and subtraction, we use rules for significant figures, and the rules are how to round our final answer. Our final answer is over here, 2.6236. And we want to round that answer. Now let's go to the rules to find out what the rules are saying. In addition and subtraction, we're going to round the answer to the least precise place. Now we just saw that the most precise place is the most decimals. The least precise place is the least number of decimals. In this number right here, 1.0236, I have 4 decimal places. That's a very precise measurement. In the following number, added on to that 1.6, I have 1 decimal place. We're going to round our answer, to the least precise place. And that is the decimal area that is the least far out. 1.6 has 1 decimal area, and that is the least precise place. The first number, 1.0236, has 4 decimal areas, and that is very, very precise. 6 here is a very precise number. This 6 at 1 decimal place is a less precise number, so we're going to round the whole answer off to 1 decimal place. So we're going to cut this off here and just scratch these guys out. But before we just drop them, does the 2 round the 6 up? No, it doesn't. So therefore the final answer is 2.6. And that's rounded off once again to the least precise decimal area that I see in the problem, and that is right there. In the second problem, it's a subtraction, and addition subtraction rules apply here. So the answer is 1.4136, and we're going to round that answer off to the least precise decimal place that we see in the problem. Now, in the problem, this has 4 decimals, and the 6 being a very precise number. This number has 2 decimal places, and the 1 is not as precise as the 6, meaning it's not as precise as this number over here. So therefore, going back to the definition, we're going to round the answer to the least precise place, the decimal area least farthest out. Well, that is this area right here. That is definitely our least precise decimal place. We're going to round off the answer right to there. So before we just cut off the 3/6, the question is, does a 3 have an influence? Does it round the 1 up to a 2? In this case, no, it does not. 5 and above will round that to a 2. So the answer remains at 1.41. Here's 2 problems we'll check out. The first one is 25.55 plus 4.7. It's going to give us a calculated answer of 30.25. Okay, let's go for precision here. Addition and subtraction rules apply. Therefore, I have 2 decimal areas. That is a very precise spot right there. And 1 decimal area is not as precise. Therefore, we're going to round off to 1 decimal area. That is the first decimal area. So we're going to chop the 5 off. Does the 5 have any influence on this number right here? Yes, it does. So the 2 is going to get rounded up. And so my final answer is going to be 30.3. And I'm going to square that off. That is my final answer. And you're going to notice that the number of decimal areas matches the least number of decimal areas in the problem. 4.7 has 1 decimal area to the tenths. The 5 over here is in the hundredths. So therefore, the lowest number of decimals is the tenths. We round this off to the tenths as well. In the problem to the right, let's check it out. I have 3 decimal areas. This is addition and subtraction, so we're concerned about decimal areas. This has 2 decimal areas right here. Therefore, my problem is going to be rounded to 2 decimal areas. The least precise place is the hundredths. We're going to take this right here and chop the 5 off. Before we do so, does the 5 round the 4 up? Yes, it does. So my rounded answer to the correct number of significant figures is 120.85. And that is my final answer. And once again, let's do a check. How many decimal places does the answer have? The answer has 2 decimal areas. And I also see the decimal areas of 2 decimal areas as being the lowest number in the problem. And so that is a good solution to our problems here. We're just going to do 2 more problems before we move on to multiplication and division. Over here, it's a subtraction problem. So I look at the subtraction problem. The calculator tells me that the final answer is 4.8656. And I know that all measurements have mistakes. And if we just said this was centimeters, and we got it. Then we have a nice measurement here. And all measurements have mistakes. Mistakes are always in the last number. The 6 is a mistake. The 7 is a mistake. Or more or less an estimate is what I'm trying to say. Okay, here we go. How many decimal places does the first problem have? The first problem has 4 decimal areas. That's pretty precise. The second one has 1 decimal area. That is less precise. Therefore, we're going to round to the least precise place. Either 4 decimal places out or 1 decimal place. We're going to round to 1 decimal place. We're going to chop off these numbers right here, crossed out altogether. The question is, does the 6 round the 8 up to a 9? Yes, it does. It is greater than 5. Therefore, my final measurement, 4.9 centimeters. And I just want to verify I have 1 decimal place in my answer, and there's also 1 decimal place as the smallest decimals in the problem too. And lastly, for addition and subtraction, we're going to go over here, and I see I have no decimal places over here. So the least precise place actually is going to be the 1s. There is no decimals, so therefore this is the least precise place. This is a pretty precise number. I have 3 decimal places. My answer is now going to be rounded to the least precise place, the 1s column. When there are no decimals used, you back off. Now you go into the 1s column. Does the 7 round the 5 up? It definitely does. So I'm going to drop the 877, and I'm going to have 786. That's my final answer. And that will match the least precise place. Changing gears, we have multiplication and division. Multiplication and division, let's check out the rules over here first. In a multiplication and division problem, we're going to round the answer to the least number of sig figs in the problem. Once again, the least number of sig figs in the problem. This has nothing to do about decimal places. This has nothing to do about precision. That was addition and subtraction. In multiplication and division, we're just going to highlight this. In the problem, I want to identify which of my numbers in the problem has the fewest significant figures. Let's check this out. So over here, 2.8723. This number has a decimal. I come in this way. I have 1, 2, 3, 4, 5 significant figures. There's a decimal point. Multiplied by 1.6, I have 1, 2 significant figures. And I would just like to tell you that your answer, okay, your answer is this. Your answer is going to have the same number of sig figs as the least number of sig figs in the problem. I have 5 sig figs and 2 sig figs. Therefore, my answer needs to have 2 sig figs. Decimal place, going this way. I'm rounding to the second place. 1, 2. There we go. That's it. This is the chopping block. These get cut off. And the question is, does the 9 have an influence on the 5? Yes, it does. It rounds it up. And my answer is 4.6. The next problem is division. It's the same rules as multiplication. I'm going to count my sig figs and make sure my answer has the same number of sig figs as the fewest number of sig figs in the problem. decimal point, coming this way, 1, 2, 3 significant figures, 1, 2, 3, 4, 5 significant figures. The fewest sig figs we see in the problem is 3 sig figs. Therefore, my answer will have 3 sig figs. Let's work on that. Decimal point, I'm coming in this way. 1, 2, 3. Boom. Drop these guys. They're gone. Does the 9 have an influence on the 0? Yes, it does. It rounds it up, and that's why we see 7.11 as my final answer. You'll notice my final answer does have decimal point, 1, 2, 3 sig figs, because that's the same number of significant figures as I see in the problem. 3 is the fewest in the problem, or 5. I choose 3. I round my answer to 3, and I end up with 7.11. Let's go on to some example problems. Okay, here we go. Example problem. It's a multiplication and division, therefore I know that I'm going to use the lowest number of sig figs in the problem. So which number has the lowest or the fewest number of significant figures? Okay, there's no decimal point, so I do know my arrow when I'm counting significant figures is coming in this way, and therefore I have 1, 2, 3 significant figures. Decimal point coming in this way, just a little reminder, 1, 2, 3, 4 significant figures. So the fewest number of significant figures comes from this side. This side has 3 significant figures. Therefore, my answer needs to have 3 sig figs. Well, there's the decimal. Let's bring my significant figure arrow coming this way now. 1, 2, 3. That's where I'm going to round to. I'm going to round to this spot right here. Now, in the past, we've always taken a lot of these numbers off. But we're not going to take every number off. The chopping block is going to stop right here. All right? So I'm going to drop the 3, 9, and the 6. I can't drop the 1s column because it's going to be a placeholder. But that can be turned to a 0. So the question is, where I round to is the 5. Where I round to, does the 4 round the 5 up? No, it does not. So my final answer will be 2,950. Leave it as that. I originally had a 4. The 4 got changed to a 0. And my final answer is 2,950. And that really makes sense. 2,950 is when I round down 2,954, I get 2,950. A common mistake students are going to have is to put the final answer as, I apologize for that, 295. A lot of students will drop the 4. I just want to say 2,950 is a lot different than 295. Always look at the original number. The original number in this case was 2,954. That is more similar to 2,950 than 295. So 295 is, although it has the right number of significant figures, it was not rounded correctly. Alright, 2 example problems for us. Multiplication and division. We're going by the number of significant figures in the problem. Okay, there's no decimal places, so whenever there's no decimal places, let's get the pen going here. The arrow comes in this way, and I count the number of significant figures as 1, 2. In this case, I have a decimal point. My arrow flies in this way. It's from an old lesson. 1, 2, 3. The fewest number of sig figs in the problem, I have 2 sig figs on the top. I have 3 significant figures down here. I'm going to use 2 significant figures as my rounding. So this number now has to be rounded to have 2 significant figures. Okay, so I'm going to round 121.95 to 2 significant figures. Well, here's a decimal point, so I know I'm counting my sig figs. Boom. 1, 2, 3, 4. There are 5 sig figs altogether in this number. I'm only telling you we can only report 2 of those. We're going to report the second one and the first one, 1 and 2. We're going to round to right there. When we round to right here, we have to first off, anything after decimal point gets dropped. That gets totally dropped. Now the question is, the place we're rounding to, let's check it out. Does the 1 round the 2 up? Does not round the 2 up, so the 2 stays the same. So my numbers I'm left with is 120. The 1 turns into a 0, it's a placeholder. So 121.95 rounded to 2 significant figures, and this sounds right. 121 will round to 120. That's my final answer with 2 significant figures. If you want to check it out, you bring your arrow going in this way, and I have 2 numbers left. Over here on the right side, here we go. The first number has 1, 2, 3 significant figures. The second number has 2. Therefore, the the second number does not have 2. The second number is 2. The second number has one significant figure. Therefore, my final answer of 15 needs to be rounded to have one significant figure. Decimal point, coming this way, and this answer right now, as it stands, has 3 significant figures. Let's round that off to have 1. That means I'm rounding to that spot right there. I'm rounding the 1. Does the 5 round the 1? Yes, it does. So now the 1 is going to become a 2. The 5 is no longer a 5. The 5 is a 0. And I leave my answer at that. 15.0 rounded to one significant figure is 20. And just for those who are wondering, is that different than 20.0? And the answer is yes. When I have a decimal point, I count like this, and I have 1, 2 significant figures. And the answer only needed 1, so this is not the correct answer. Alright, in this problem, please forgive me if I already did this problem before. I had a little technical difficulty a second ago. Okay, here we have a division problem with 7.50. 7.50 has 3 significant figures. 21 has 2 significant figures. My final answer has a lot of significant figures. Alright, let's calculate the sig figs. Decimal point, my arrow goes right through the 0, and now I count. I have 1, 2, 3, 4, 5, 6, 7 significant figures. I have 7 sig figs, so therefore I have to round to the fewer number that I see in the problem, either 3 or 2. 2 is definitely a fewer number than 3 sig figs, so I'm going to round off to the second significant place, which is right there. Does the 7 round that up? Definitely does, and when it does, it turns into a 6, and I drop these guys over here. All dropped. My final answer is 0.36. Rounded off to 2 significant figures. Once again, you're going to notice that I'm stressing the number of significant figures in multiplication and division, and I am not stressing the decimal areas. Decimal areas is the least precise place, and that is for addition and subtraction only. That is the end of the tutorial. If you need any more help, please let me know. My after-school hours are Tuesday after school. Come and visit me. Enjoy.